Good day everyone, I am Jarideep Pitiligana and in this video, we are going to talk about four compounds and their molecular structures. Molecular structure is actually the correct placement of atoms in a molecule or a polyatomic ion. For example, in the molecule of our diamond, it has a structure tetrahedral. So knowing the molecular structure of a compound is very important because it tells us how the molecule behaves in nature. So its characteristics and properties is greatly dependent on its molecular structure. We need to look at the valence shell electron repulsion theory because this helps us predict the molecular structure. This theory states that electron pairs in the central atom arrange themselves to minimize repulsion, and this is by maximizing the distance between them. So we need to follow four steps to construct our molecular structure. First, the Lewis structure. Second, we need to count the number of electron regions. This could be lone pairs in the central atom or bonds, either single, double, or triple. Third, we need to identify the electron pair geometry, and this referred to a table. And fourth, we need to count the lone pairs to determine the molecular structure, and this is also provided in a table. So this is a table of molecular structures. We have here number of electron pairs, and the electron pair geometry pairs molecular structure is also specified in this table. So let's head into our first example. We have chlorine trifluoride. It has 22 valence electron and its Lewis structure is this. We can see that it has 1, 2, 3 bonds and it has 2 lone pairs. And thus we can use structure to determine the region, which is what we need for step 2. So it has 5 regions. It is composed of 2 lone pairs and 3 single bonds. In step 3, we need to look for its electron pair geometry, and thus we refer to the table. So it has 5 number of electron pairs, so we can readily see that its electron pair geometry is trigonal bipyramidal. Step 4, we have the molecular structure, T-shape. This is because it has 2 lone pairs and 3 single bonds. So this referred to the table, and we actually find that in the 5 number of electron pairs, since it has 2 lone pairs, so this is actually the structure that we are looking for, T-shape. This figure shows us that it has 87.5-degree angle between 2 of its bonds. And this figure shows us that its lone pairs is not located on the same plane. For our second compound, we have bromine pentafluoride. So it has 42 valence electrons, and this is its Lewis structure. So we can see that it has 1 lone pair and 5 single bonds. So our regions would be equal to 6. The electron pair geometry, octahedral. Step 4, it has the molecular structure square pyramidal. For our third example, we have the carbonate ion. It has 24 valence electron and its Lewis structure is this. Let's try to see if this will be the same with our molecular structure. Step 2, we have 3 regions, and so our electron pair geometry is trigonal planar. This is actually the same now with our molecular structure. So we actually see that this is different from our Lewis structure. Down to our last example, we have iodine dichloride ion. It has 22 valence electron and this is its Lewis structure. So it has 3 lone pairs and 2 single bonds. Number of regions will be 5. Our electron pair geometry is trigonal bipyramidal, and our molecular structure, this is now linear, and it has 180-degree angle between the 2 single bonds. So in this video, we talk about molecular structures. We have VS-EPR theory. We also talk about the steps in forming molecular structures. And finally, we formed the molecular structures of chlorine trifluoride, bromine pentafluoride, carbonate ion, and iodine dichloride ion. And that's it, guys. I hope that you learned something in this video. Thank you so much for listening, and may God bless us all.